Triggers and order of execution. Hello and welcome back to our Apsynergy Learning session. My name is Raphael. I'm the founder of Apsynergy, a leading European-based Salesforce partner, helping businesses and NGOs for the past 10 years. Along the way, I've worked on many different projects for small and large organizations, for nonprofits, for foundations, for NGOs. And during the course of my Salesforce career, I have trained hundreds of Salesforce users, admins, and developers. Today, we're going to learn about Salesforce Triggers and order of execution. Once you have completed your session, fill in the quiz and get your course validated. Make sure to share our content with your colleagues working on Salesforce. It's free. Check Apsynergy Learning on YouTube for additional free content. Now let's get started. Today, we're going to touch upon one of the most important aspects of Salesforce development, and that is triggers and order of execution. Here are the topics that we will cover in this session. Before we get started, let me tell you in a few words, what is a trigger in Apex? Whenever a record is inserted, whenever there is a database event that happens to a record, and we want to automate what happens to a set of records, and we are using Salesforce development, we write triggers. There are two types of triggers. Number one, a trigger that executes before the event happens, and number two, a trigger that executes after the event happens. There is a set defined order of execution when it comes to triggers. It's crucial to understand in which order triggers are executed. Make sure to learn this by heart so you don't forget it in any case. Because in everything you do in Salesforce development, you will have to take into consideration the order of execution. Let's first talk about this topic only. That is order of execution. Once we'll have covered that, we will also learn about use cases for triggers, types of triggers, difference between before and after triggers, the execution of triggers, basic structure of triggers, does the code itself sit in the trigger or elsewhere, and finally, trigger best practices with some sample code snippets. Let's have a look. So in actual detail, what is Salesforce order of execution? If you type Salesforce order of execution in Google, you will find this article in the developer handbook or developer guide. And there's a lot of information which is too much for a single slide, so the best is just to look at it online. So what happens when you fire a trigger? And this is the order in which everything happens in Salesforce. So first of all, Salesforce server will load the original record and the new values from the request. And then a number of things happen here. You can check it online and read it for yourselves. But there are a few things I would like to explain in the rest of these items here. So here we have flows, which is the configuration point and click flow designer or flow builder as it's called. Then we have here, which is part of the actual trigger, so the before trigger. Then we have validations, system validations, which take place. I can let you read these here, for example, validation rules. Then the system is going to run through duplicate rules. So duplicate rules in the configuration, you can find this by looking at matching rules and duplicate rules. This is the functionality to prevent duplicate records from entering or from being updated in Salesforce. At this stage, the record is actually saved to the database, but it is not committed yet. Then we're going to look at the after triggers in the trigger and the related handlers. Then Salesforce is going to execute the assignment rules. So assignment rules work typically with leads and cases and some other objects. This is to assign lead records or case records to different users based on rules. Salesforce then executes auto response rules. This is also related primarily to Service Cloud. So auto response rules will automatically send an email, for example, based on certain rules related to cases. Then we have workflow rules, the piece of functionality that has been retired by Salesforce to be replaced by Flow. Then we have escalation rules. This is also used in the context of Service Cloud. And for example, a case will be escalated based on certain criteria determined in a rule. We're going back to Salesforce Flow automation, which are executed in the following order, but not guaranteed. Then we're number 14, and we're going to entitlement rules. This is also related to Service Cloud. So what is the service level that's entitled to my customer? There's a bunch of rules that dictate that, and the order of execution. We'll run through those rules at this stage. Then we're going back to what happens in flows. Then we're going to have roll-up summary fields, which are going to be calculated on the parent record. Same here, again, roll-up summary fields for cross-objects workflows. Finally, Salesforce is going to execute criteria-based sharing evaluation. So does this record need to be shared with, for example, other users? And then the last two steps are commit all DML operations to the database, and then execute post-commit logic, such as sending an email, etc. So it's a lot of information, and better if you look at it online than on the slide. So let's come back to our topic of Apex triggers. Primarily, use triggers when standard Salesforce functionality does not cater to your requirements. Don't forget, consider AppExchange applications or components before considering triggers. These have been tested and are in use, and they may fit your client's needs. Triggers are used to carry out activities depending on certain criteria, modify related records, or prevent certain processes from taking place. Triggers listen for certain database events, for example, a record being inserted, updated, deleted, etc. Moving ahead, let's discuss possible use cases of triggers. Triggers can be executed by the following events: insert, update, delete, merge, upsert, and undelete. By using triggers, we can compare data before and after a change is made. We can create a new record or update an existing record. We can delete records. And we can interact with external data and web services. The important thing to note about triggers is their type. There are two types of triggers: before triggers and after triggers. Let's discuss what they basically are. Before triggers are used to update or validate record values before they're saved to the database. You can perform insert, update, and delete events in this trigger. After triggers are executed after records are committed to the database. This means you can make any more modifications to the updated records without releasing another DML statement. They are used to access field values that are set by the system, such as record IDs or last modified date fields, and to effect changes in other records. The records that fire the after trigger are read-only. You can perform insert, update, delete, and undelete events in this trigger. The main difference between before and after in triggers is that all the code written in the before update triggers executes before DML is committed to the Salesforce database. Code written in after trigger executes after the commit is made. Before being stored in the database, before triggers are used to change or validate record values programmatically. After triggers are used to retrieve system-defined field values such as record IDs or last modified date fields, as well as to make modifications to other records. After triggers are great for using the values you just created to create new or update existing records. Now let's look at the actual execution of the triggers of a given object. Triggers are always related to single objects or start with a single object. Thus, if you create a new contact record and there is a trigger associated with the contact object, it will fire. The preceding trigger actions will fire first. They'll validate data, compare values before and after a modification, and update data that's about to be saved, among other things. Then the information is saved to your organization's database. Then the after trigger actions take effect, which can include things like creating connected records or searching for related records and doing something with them. All of this is predicated on the record ID that was just stored. The trigger then sits back and waits for the contact object to do something else. Now we will discuss the structure of a trigger or syntax. The trigger keyword is the first part of a trigger definition. The name of the trigger is then followed by the Salesforce object with which the trigger is related, and the conditions under which it fires. As you can see in the example, we have our trigger called recipe. That's listening to a custom object called recipe__C. It is going to work after a new recipe is inserted into our org or after an existing recipe is updated. So where does all this code go? Triggers can be used to execute Apex code. However, it is necessary to follow best practices while writing an Apex trigger. So far, we've talked about one option. for where your code lives, and that's in a separate file called a class and not within the actual trigger itself. But you do have another option. You could put all business processes within the actual trigger. This seems simpler, right? There's just one trigger per object and it can contain all the things you need. But for lots of reasons, this isn't best practice. Why is that? Because when you create more atomic pieces of code, then it's easier to reuse code, and this is big. So if you want to use the same piece of code in multiple parts of your trigger or in other triggers, then you'd have to duplicate your code in all the places you need to use it. This kind of duplication will just give you more work and increase technical debt. It's also easier to read code and understand what's going on if it's broken into smaller chunks. This is a huge part of efficient code maintenance. There's nothing more frustrating than going back to code which is long and convoluted, which means you need to spend more time trying to figure out what it does. You may have heard of unit tests. They're the code you write to make sure that everything is working as you want. Unit tests are required before you can deploy your code to production. And it's easier to write distinct unit tests when you're dealing with smaller sections of your code. While I'm talking about best practices, I mentioned that there would only be one trigger per object. Why is that? Because you can in fact control the order in which the code will run if you only have one trigger for each object. So there are a few best practices we are going to discuss. One trigger per object. One trigger per object is always preferable. You don't have control over the sequence in which triggers are executed if there are numerous triggers per object. Logicless triggers. It's best not to write logic or methods in the trigger. If you add logic and triggers, code reusability is reduced and test classes are difficult to write. Number 3, context-specific handler methods. We will see in a moment an example of context-specific handler methods. Number 4, bulkify your code. Bulkify your trigger code whenever possible to avoid hitting governor limits. Number 5, avoid using DML statements and SOQL queries inside for loops. Before exceeding the governor limit, a single Apex transaction can receive a maximum of 100 SOQL queries. The governor limit will throw a runtime exception if the trigger is called by a batch of more than 100 records. Also, if possible, combine related objects into a single query. Number 6, using collections, streamline queries, and efficient for loops. Apex collections are essential for effectively querying data and storing it in memory. Using collections and simplifying SOQL queries together can significantly aid in generating efficient Apex code and avoiding governor constraints. Number 7, querying large datasets. A total of 50,000 records can be returned by SOQL queries in a single request. If returning a high number of searches exceeds your heap limit, you must utilize a SOQL query for loop instead. Through the use of internal calls to query and query more, it can process numerous batches of records. Number 8, use future appropriately. It's critical to create your Apex code in such a way that it can handle a large number of records at once. When you use a specific future method, the method executes when Salesforce has available resources. The future method in the event of a trigger calls out to ensure that the current transaction does not have to wait for a call-out answer. Number 9, avoid hard-coding IDs. It's critical to avoid hard-coding any form of value in Apex code, such as IDs, while deploying Apex code between multiple environments or from sandboxes to production. To keep such hard-coded values, if possible, use a custom label or custom setting. Number 10, avoid calling a batch from a trigger. When a batch is called from a trigger, there's a good risk it will exceed Salesforce's governor limit. One of the best practices I mentioned a minute ago is bulkify your code. But what does this mean, to bulkify your code? Well, for example, a trigger could be invoked by an API call that inserts a batch of records. So if a batch of records invokes the same Apex code, all of those records need to be processed in bulk in order to write scalable code and avoid hitting governor limits. While designing triggers, we should always ensure that our trigger will be able to handle multiple records at a time instead of designing a trigger that can handle a single record. Always keep in mind that avoid using SOQL queries inside for loops as per the example here. Similarly with DML, Always apply DML operations on a collection of records instead of performing on each record individually, because there is a governor limit of 150 DML calls. Also, there is a governor limit of 200 SOCL for asynchronous Apex and 100 SOCL for synchronous Apex. Next, we are going to discuss that there shouldn't be a DML statement in for loop. And it's a very common mistake that queries or DML statements are placed inside a for loop. There is a governor limit at a maximum number of SOCL queries and DML statements. Insert, update, delete, undelete. So how can we deal with this? Database operations are invoked once per iteration of the loop when these actions are placed inside a for loop, making it very simple to approach these governor restrictions. So what you can do is you can move the database operation outside the loop. Also, you can use query results for further operations to reduce iteration. Moreover, invoke DML once by using a data list. As you can see here, we have performed a sample trigger to create a roll-up summary trigger for the account to count the number of contacts associated with it. It's a trigger on contact. You will find this code snippet in the course after the video. You can use more best practices. For example, you can create a class with a static Boolean variable to avoid a recursive trigger. Let's say for some reason you want to update the account name each time the account gets updated. Now, if recursion is not handled, you may encounter this error: maximum trigger depth exceeded. To avoid recursion on a trigger, make sure your trigger is getting executed only one time. You can use a static Boolean variable in Apex class and check the variable in Apex trigger. If it is true, then execute your logic and then make it false so that trigger cannot execute again. You can use query for IDs dynamically in code instead of using hard-coded IDs. This prevents code breaking when you spool up a new sandbox or scratch org, because IDs in sandboxes or scratch orgs are different than in production. Consider invoking asynchronous methods with a batch of records. The future annotation is used to execute a method asynchronously in Salesforce. For example, we can use the future method to make a web service callout from an Apex trigger. Methods with the future annotation must be static and can only return a void data type. The parameters must be primitive data types, arrays of primitive data types, or collections of primitive data types. Salesforce describes a trigger framework with the following characteristics. Because of the built-in bulkification, it's scalable. For each record, there is a clear indication of what logic is run and when. Because functional methods and classes are separated, they are reusable. Atomic, allowing you to avoid or bypass certain triggers when necessary. Optimize, by using the least amount of SOCL calls possible, avoiding recursion, and sharing result sets throughout the execution cycle. Triggers are a strong tool that, when used correctly, when you have a clean trigger framework, can achieve amazing things. So by using best practice, we can avoid complexity and technical debt. Triggers should be, in my opinion, logicless. Putting logic into your triggers creates untestable, difficult to maintain code. It's widely accepted that a best practice is to move trigger logic into a handler class. According to this trigger framework, a single Apex trigger is all you need for one particular object. If you develop multiple triggers for a single object, you have no way of controlling the order of execution if those triggers can be run in the same context. Logicless triggers. If you write methods in your triggers, those can't be exposed for test purposes. Also, you can't expose logic to be reused anywhere else in your org. Context-specific handler methods. Create context-specific handler methods in trigger handlers. My recommendation would be to create a specific handler method just for after insert. If you were to implement new logic that ran on after update, simply add a new handler method for it. This piece of code can be found in the curriculum. Bulkify your code. Bulkifying Apex code refers to the concept of making sure the code properly handles more than one record at a time. Avoid SOCL queries or DML statements inside for loops. An individual Apex request gets a maximum of 100 SOCL queries before exceeding the governor limit. So if this trigger is invoked by a batch of more than 100 account records, the governor limit will throw a runtime exception. Thanks for watching this Apsynergy Learning session about triggers and order of execution. We hope you learned a lot. Let us know if you have feedback and suggestions. This is very important for us. You can drop me an email using the site contact form. We are looking forward to helping you becoming an outstanding Salesforce professional. Please share this content with your colleagues and friends using Salesforce. And make sure you visit our YouTube channel and our blog to continue improving your Salesforce skills. Here's something else. If you would like to become an Apsynergy content contributor and share free Salesforce education content with us, just get in touch. Make sure you check our library of free Salesforce training to continue to improve your professional skills. Thanks for attending and looking forward to see you in the next session. Bye.